Hello everybody, Eric at Voke Performance again. Today we're going to talk a little bit about clutching. One of the reasons I want to bring this topic up is because I field a lot of phone calls and, and messages, private messages regarding clutching, and one of the most common things or mistakes that we encounter as tuners is this question or comment about, well, I'm running 72s or I'm running, 76s or whatever, as though the single most important reference is the weight. And I titled this video, it's not what it weighs, but rather where it weighs, for a very, very important reason. This is something that I hope is the takeaway from this little segment. We'll keep this quick. There's going to be some terminology in here that I use to describe some of the different components and parts and the way that I map a cam arm and why this is extremely relevant. Hopefully we can kind of summarize this into something you get. Either way, what I wanted to do was kind of show you how different some of the different weight configurations are and how these different weights play a role in where they weigh. So if you wouldn't mind coming over here, let's just take a quick look here at some of this. These are some of the common offerings from the industry. You'll see MTX weights, and a lot of this stuff comes with various different components to install in various different locations in the weight. You'll see these have a couple different options here where you can put it in the center of the weight or in the tip of the weight. You'll see that a lot of magnet variants will offer either 3 or 4 holes to apply a different number of neodymium magnets. These are an exciting new product right here that was recently developed, born out of the exact need to answer problems where we need to place weight in very different locations. This one's unique in that it has both neodymium magnets that can be applied in 3 different locations, both heel, undertoe, and toe, as well as, this is kind of cool, won't spend too much time here, but these are, carbide inserts, you'll see, and the carbide inserts can be inserted in longitudinally in the weight with various set screws applied. You can also apply depth stop so that these can be moved up and down in the weight. This is kind of a cool weight. Anyway, excited to do some testing there. And anyway, as you come across here, you'll see this is a conventional rooster. Very, very, very good weight. It's been around for a long time. Comes with a myriad of different calibration equipment. This is a weight that is a Voke weight. We've used this for many years. You'll see this is a full-bodied weight, we call that. And then we have a toe screw, which we can use to change the what's called the undertoe weight. And we'll talk a little bit about how that affects things. So again, different variants here. This is a standard. I just put this out here. This is a standard 1068. It's a very common weight in the Polaris lineup. The 1068, the one thing that you'll find very common is most weights mirror this profile. When somebody says weight profile, they're actually talking about that upper roller surface right here. So anyway, and so just kind of get an idea of how these are shaped. We have tip light, full body. We have what they call belly cut or heel relieved. These are a Cutler weight, very similar to some of what we pointed out in that new Bikeman weight that has the ability to put weight longitudinally in the weight. Also can be adjusted in terms of length. And then this is the new Boondocker weight that they developed last year, utilizing that same technology where you drop various length pins in to modulate the weight. So other than that, just more magnet weights. I just want to give you an overview of that, but I want to just come over here. In fact, we'll grab my marker and we'll come over here to my makeshift whiteboard here and talk about the main thing. Somehow I managed to lose my marker, so bear with me while I find that. It's official. I lost it. We're going to use a blue one. All right, that's how you know this is rather impromptu. Okay, so we're going to talk about weights and why this is so important. So when I get that call about, hey man, I'm thinking about putting heavier weights in. Well, what problem are you trying to solve specifically? And this spins into a lot of other issues, and I'll do some more horrible drawings, but I want to focus right here to begin with. When a weight sits in a drive clutch, this is called a cam arm. This is the axis I divide this into an X and Y axis, so this is kind of Voke-specific information, but this is what I found the best way to both map an arm as well as explain it. So we have 4 quadrants, A, B, C, and D, all based on the center axis of the weight. This is the way the weight sits in the drive clutch. And the point here is that this is what we call undertow. So undertow weight, you can see that if all other weight was removed from this, the undertow would be its force would be applied backwards during the initial engagement, right? So obviously you have to have less undertow than you have, say, body weight over here, right? So body weight's divided into typically 3 different areas, and we call that heel, center, toe. So when somebody says add heel weight, they're typically talking about that. So these are just a few of the things that we as tuners kind of go to with respect to how we tune a weight. The role that undertow plays is it'll raise engagement and make it feel a bit greasier as well, because it literally holds against the other weight that's out here. Heel, center, and toe. And a good rule of thumb, and this isn't, I'm going to oversimplify things, so the really techie guys that watch my videos, feel free to PM me about this, but I just want to say that this is for the masses, okay? This is a little bit general, but a good rule of thumb is that the stuff closer to the pin affects the pre-shift, and the stuff farther away from the pin affects the final shift. And obviously, where this weight is, as it swings out against a roller, which, you know, there's a roller right here, right? So that force, as this swings out, that force forces this pin to move down that axis, right? And as it does, that weight swings out, closing the movable sheave and causing the shift. This is one of the 4 components in the clutch system. And it happens to be the one that we most typically go to for tuning. And that's why you see a lot of a push, if you will, for all these different variants of cam arms. So just understand, I refer to this relationship here as relative roller pressure. As you, say, increase undertow, you're going to have less relative roller pressure during the pre-shift, right? As this shift breaks over this axis, then suddenly all of this begins to apply roller pressure to affect the shift. The more you have in the heel earlier, because it's leading, if you were to point or to put those points where you might see magnets placed or other weights, you can see that it's leading, right? This heel is leading. So if you want more relative roller pressure, in other words, more control of the RPMs lower in the shift, then you go here. If you put a bunch in the toe, obviously you have slightly lower relative roller pressure during the shift, but you also at end shift has significantly more, because the farther away from the axis it is, the greater relative roller pressure it will have. So I don't want to get, like I said, I don't want to get bogged down in the details. That's just a general overview of it, but it's critical to understand why we're placing weight down this axis here across these points, as well as changing both undertow and now on the Bikeman we can change under heel or belly weight, and some of the other things that like I said, I want to keep it simple, but these differing profiles here, sometimes you'll hear somebody say it's a humpier profile, more aggressive profile. A lot of times you're going to find that's right in here in this roller profile area, but everybody's kind of settled on the Polaris 10 profile as a very good one with minor deviations from that. But all of this is, of course, relative to your engagement spring or primary clutch spring, and then, of course, your secondary, which is torque sensing. And the secondary, we may have to do another video on this, but I'm just going to throw this out there. If you were to think of, people talk about helix or secondary cam, whatever term you want to use, they have typically some sort of an angle applied to it with a roller that rolls down, that you can appreciate that it's going to take less force to push that roller down if this is steeper, and more force as that gets shallower, right? So the less force it would take, and you might remember this, the steeper the angle or the lower the force that you have to apply in order to cause this shift is going to effectively lower your RPMs, right? So steeper, right? Steeper equals lower, right? You can modulate angle throughout the shift. There's a number of different philosophies on how to do this. And of course, this is why CVT drive systems are both good and bad, because there's so many different applications with respect to how you tune one. But the other side of it is it can be complicated. People can make really big mistakes and miss really big things. So don't leave the stuff on the table. But I just wanted to make sure that we just had a basic understanding. Cam profiling, when you hear something like a 60-44 or a 60-36 or whatever, or a straight 42, those are references to this angle here. And typically, if it's followed by a P or an F, that's an acronym for full or full progressive, or just progressive, which is all the same thing. So remember that at the end of a helix number, F or P. If you see a small, like a lot of them you'll see are like a 0.36 or a 0.40. These are just common distance applications for the pre-shift section that we might leave in that particular angle. So as we develop helixes, you'll see crazy stuff. There's shaped in all different ways. And a lot of the reasons for that is because we're trying to solve a certain problem. We go to the weight, we go to the springs, and then we go to the helix to try to solve all these problems. This is really a general overview of clutching and some of the functionality of these things. I really wanted to focus on the diversity of weights that are out there. And the main takeaway here is that it isn't about what your weight weighs. I cannot stress that enough. I don't care. If you tell me you got 68s, it doesn't do me any good at all. I want to know, when you communicate with me, more about the weight than that. So if it's a Polaris 68 and you're comparing it to, say, a Polaris 70, those two are very similar profiles with a similar belly cut, and we'll have the same result. So relevant, right? But you could respect the fact that if we had a 68 and all the weight was in the toe, your final shift RPMs would be quite a bit lower. Anyway, hopefully this was quick, enough information that it gets you thinking about this stuff, and then also for relevant conversations, not just between you and I, but between you and your tuner, or just thought to come up with a better setup for the weekend when you're racing your buddies. But anyway, thanks for tuning in. Again, just a quickie from the Volk Shop. Take care.